Week 9, Earth, Sun, and Moon. Earth, Sun, and Moon, dancing partners. The Sun, Earth, and Moon interact, move, and work together in a series of patterns. Their movements are so smooth and predictable that some say it looks like they're dancing. The Earth spins on its axis, turning toward the Sun and then away from it every 24 hours. As you know, that's one full day. As it spins, the Earth moves around the Sun on a journey that takes 365 days, otherwise known as a year. And you know this as well, we've discussed it, 365 and a quarter of a day, so it's like 5 hours and 50 minutes roughly, but instead of randomly having a wonky quarter of a day, that's why every 4 years there's an extra day on the calendar in February, also known as a leap year. And it's been a crazy leap year, hasn't it? And as Earth spins and revolves, the Moon moves around the Earth. The Moon completes a passage around the Earth every 29.5 days. As the three dancers, the Earth, Moon, and Sun, go through their movements, they create the patterns of day, night, years, seasons, tides, and moon phases that we experience on Earth. Long before humans knew what caused these patterns, they lived their lives around them. The Sun is the most dominant feature in our sky. People have always moved and slept by the pattern of day and night, created by Earth's rotation. They planted and harvested crops by the seasons, caused by the Earth's tilt and revolution around the Sun. They tracked the passage of time by days, seasons, and years. They made up legends and myths to explain the sun's influence on their lives. You'll see an awesome diagram at the bottom here of the Earth spinning on the axis, the Moon going around it, and us going around the Sun. So there's a lot going on. Like the Sun, the Moon has also been a large presence in humans' lives. From ancient times, they watched the Moon rise and change in shape each night. They noticed the pattern of its phases, a pattern that repeated itself without change every 29.5 days. They watched lakes, bays, and oceans rise and fall in a daily pattern and noticed how these tides were linked to the Moon's movement. And very rarely, something special would occur. The full moon would darken at night, or the new moon would block the sun for a short time in the middle of the day. No wonder we've been curious since ancient times about how the sun, earth, and moon interact. This week, we'll see how rotation and revolution cause days and years. We'll see how the tilt of the earth causes our seasons. We'll take a look at the phases of the moon caused by the moon's revolution around earth. We'll also see how the moon causes the tides to rise and fall, and what causes an eclipse. The Sun, Earth, and Moon have been dancing together for millions of years, and the results of their movements impact all of us. Read on and learn the science behind the dance. Night and day, 4 seasons in a year. The Earth is always moving in space. Even though we don't feel ourselves moving with it, the movements have a pretty big impact on us. Let's start with the simplest of Earth's movements, its rotation. Earth rotates or spins on its imaginary axis once every 24 hours, causing day and night. What started the Earth spinning? Scientists don't know, but some theorize that long ago, something big bumped into our planet and started it spinning as it traveled around the Sun, and it's been rotating ever since. By the time Earth finishes revolving around the Sun, it's completed 365 and a quarter rotations. We've decided to call one complete revolution around the Sun a year. Earth does not rotate around a vertical axis. Instead, the axis is tilted about 23.5 degrees. The tilt is what causes most parts of the world to have 4 distinct seasons. As Earth revolves around the Sun, its axis is tilted toward the Sun for part of the year and away from the Sun for part of the year. When the northern hemisphere is tilted toward the Sun, it's summer there. At the same time, the southern hemisphere is tilted away from the Sun, so it's winter there. So for example, when we have Christmas, it's snowing. Australia in the southern hemisphere, when they have Christmas, it's warm because of that tilt. Crazy, isn't it? This happens every year on about the same date, June 21st. This day marks the summer solstice and is when the northern hemisphere has the longest amount of sunlight and the shortest night. 6 months later, on December 21st, the northern hemisphere experiences the winter solstice, the day when there's the shortest amount of sunlight and the longest night. And the best thing about that day is after that, it all gets brighter. So after that December 21st winter solstice area, our shortest day of the year feels so long because we're lacking that sunlight. But then on December 22nd, or however it falls, the days get longer and I feel like throwing confetti. So that's one beautiful thing about this quarantine, is our days just keep getting longer, and I think it's beautiful. As the Earth travels around the Sun, it reaches a point twice each year when it's halfway between winter and summer. On those days, neither hemisphere is tilted toward or away from the sun. These days are called equinoxes, which means equal night. So equal, and then nox would be the night portion, right? On equinoxes, there are about 12 hours of sunlight and 12 hours of darkness in both the northern and southern hemispheres. There are only 2 equinoxes each year, on about March 21st and September 23rd. March 21st is called the Vernal Equinox in the northern hemisphere and signals the first day of spring. So vernal refers to spring. September 23rd is called the autumnal equinox. You guys know the word autumn or fall. In the northern hemisphere, it is the first day of fall. It's interesting to remember that as we experience each season in the northern hemisphere, people who live in the southern hemisphere are experiencing the opposite season. Here we go. Yep. So for example, Australians have summer vacation in December and their first day of spring is in September. Crazy. Moon phases. The moon does not give off any light of its own. When the moon looks white, it's actually reflecting the sunlight shining on it. As the moon revolves around Earth, half of it is always lit by the sun, but because of the moon's position, we only see part of the lit portion. The lit part of the moon that we can see from Earth is called a phase. Have you noticed that the moon is not only out at night? Sometimes we see it during the day. About once each month, the sun lights the side of the moon that's facing away from Earth. On that day, the side of the moon that faces Earth is completely dark. We call that a new moon. So of course you can see all those awesome moon phases. We have the full moon, waxing gibbous, first quarter. So you see that first, it looks like half, right? But because, think about the sphere, the whole circle, 1/4 of the entire moon is lit up. Waxing crescent, new moon, is like, hey, it's dark and it's gonna come back again. So wax. Oh my heavens, I just did that in the wrong order, you guys. I totally did. Oh, that's embarrassing. Okay, back up. Let's start at the new moon. That'll be easier. I was going counterclockwise and it's going counterclockwise. Okay, so the new moon, we have the waxing crescent, then the first quarter, which I've already explained, waxing gibbous, and then the full moon, like it's fully lit and bright on our side of things. I was about to say wax on, wane off, and that's how I remember it. And then I got to the waning crescent part. I'm like, wait a minute, did it the wrong way? Okay, so after the full moon, then it starts to disappear again, if you will. So you have the waning gibbous. Gibbous is almost full, but not quite. It's missing that sliver. And then third quarter is, this angle's kind of hard to see. When you have that quarter is dull, right? But that quarter of the entire sphere is lit up. And then the waning crescent, and you guys know what a crescent is. The new moon is always in the sky during daylight. After that, we see a larger and larger portion of the lit moon every day. For about 2 weeks, the lit portion of the moon is waxing or getting bigger. At first, it's only a thin C shape called a crescent. Each day, the crescent gets larger. This phase is called the waxing crescent because it's a crescent shape that's getting bigger each night. About 1 week after the new moon, we see about half the moon lit. This is called the first quarter moon because it happens 1/4 of the way through the moon cycle. The moon continues to get larger and it rises a little later each day, so we now see it in the evening. From Earth, we see a lit side that's more than half lit, but not quite fully yet. This shape is called a gibbous because the moon is still waxing. The moon phase between first quarter and full moon is called the waxing gibbous. So one night I looked outside and said, oh, it's a gibbous moon tonight. And Jason was like, what? I'm like, a gibbous moon. Oh my goodness, I'll teach you some science. So, and then, you know, I gave him the phases of the moon lesson, and he was like, okay. I'm like, here, I'll use it in a sentence for you. Give us this day our daily bread. And he's like, you're ridiculous. To which I responded, yeah, I know, but gibbous, it's a fun word. Around 2 weeks after the new moon, the moon is halfway through its cycle. From Earth, we see its entire lit side, or full moon. The full moon is always in the night sky. From this point on, the lit side of the moon will be getting smaller or waning. For about a week, it will be a waning gibbous, getting smaller until about only half of it is lit on the third quarter. After that, it'll be a waning crescent and get smaller every night until it's once again in the position that none of the lighted side is visible from Earth, the new moon. On to everyday science, eclipses. Imagine you're playing outside in the middle of the day and the sun disappears. The sky darkens the air, and the air chills. It would be a scary thing if you didn't know it was a solar eclipse. Every now and then, when the sun, earth, and moon line up just right, we get an eclipse. An eclipse is when an object in space comes between the sun and a third object that casts a shadow on that object. Two kinds of eclipses can be seen from Earth. A solar eclipse occurs when the moon blocks our view of the sun, and a lunar eclipse is when the moon travels through the Earth's shadow. A lunar eclipse can only occur during a full moon, when Earth is lined up between the sun and the moon. The sun behind Earth shines on our planet, and the moon passes through the shadow created by Earth. The moon doesn't get totally dark. Instead, it turns a dark orange color when it's in a shadow. Everyone on Earth sees a lunar eclipse. A solar eclipse can only happen during a new moon, when the moon is between the sun and Earth. During a solar eclipse, the new moon, which is out during the day, blocks our view of the sun as it slowly passes across the sky. A solar eclipse is rare because it only affects a small portion of Earth. So if you don't live in that small area, you won't see the solar eclipse. If you get to see a solar eclipse, you'll be very lucky. You must be careful not to look directly at it without a special protective viewer. When that happened a few years ago, I actually had friends who would, they looked at their car window, and so they got to see the reflection of it. I didn't go out, which was really sad, to see it in person because I was like, oh, I don't have the protective gear and I didn't want to hurt my eyes. So if I had been a little more creative or researched first, then I would have had it down. When you look at the diagram of moon phases, you may wonder why a lunar eclipse doesn't occur every full moon, or why a solar eclipse doesn't occur every new moon. Well, usually the moon revolves completely around Earth without the moon moving into Earth's shadow or the moon's shadow hitting Earth. It's only rarely that the moon is at the exact right angle to cause an eclipse. So you can see, according to the diagram, that the eclipse is named after what is being blocked, right, by the sunlight. So what's being blocked. So the solar eclipse, the moon gets in the way and blocks the sun. The lunar eclipse blocks, well, my hand is like huge here, blocks the sun from shining onto the moon. So that is how I remember that. Otherwise, I would get them all mixed up. The sixth question, how does the moon cause the tides? The tide is the rise and fall of water in large bodies of water. You can see water rise for about 6 hours, fall for 6 hours, rise again, and fall again on a regular cycle. Tides occur because of the pull of moon's gravity on different parts of the Earth. As Earth rotates, different areas are facing the moon. At the part of Earth that faces the moon's gravity actually deforms the Earth, pulling it into a very slight egg shape. Water is not as massive as land, so the water on top of the Earth is pulled up to a higher level. At the same time, water on the opposite side of the Earth is pulled up to a high tide. What about low tides? Well, there's only so much water to go around on Earth, so the areas halfway between the high tides, the water contracts closer to Earth. During a 24-hour Earth day, there's a high tide, a low tide, a high tide, and another low tide. There's a 6-hour difference in high and low tides and 2 of each tide each day. In the back, we have a biography. Dr. J. Craig Venter. When you're sick, what do you do to feel better? Most of us take medicine, but that doesn't always work. Imagine having medicine personalized just for you. Thanks to Dr. J. Craig Venter, this could be possible someday. Dr. Venter's one of the world's leading scientists in genomic research. Genomes are full sets of chromosomes that include all the traits that we inherit from our parents. That's going to come up again in our life science unit. So by learning more about human genomes, Dr. Venter has actually made it possible for doctors to one day create special medicine. Born in 1946, Dr. Venter is an American biologist. He was far from an A student in elementary school and would rather have gone surfing or boating than to be in school. And Albert Einstein was the same way. He was so deep in thought, it seemed like he wasn't paying attention most of the time, and it frustrated his teachers. But thankfully, in the later years here in teaching, we know that, you know, if you don't seem to be paying attention, there's more going on, right, than meets the eye. So there's a lot of potential for all of us. But after graduating from high school and going on to college, it wasn't long before he became an important scientist in the 21st century. Maybe he'll make it into that musical, right? Now Dr. Venter has left medicine behind, at least for a while. A few years ago, he helped start a company that uses science to produce cleaner fuels. Their goal is to find a way for us to create less pollution when we drive. That would be awesome. Who would have thought that one person could do so much for both medicine and the environment?